Hello, my name is Rob Hirschfeld, and I want to talk for a little bit about infrastructure as code. For some people, that's a trigger warning. Infrastructure as code is a very hot topic nowadays. However, it's also one where everybody seems to have their own definition. So as soon as you get into a discussion about it, you might be discussing different things than you think about. And so when we hear infrastructure as code, we get very excited at RackN because we provide what we think of as a lot of infrastructure as code capability at the physical layer. And yet, when we have these conversations, a lot of people assume that that means cloud, or that means one product like Terraform, or that means everything has to be in Git, and that conversation ends up being sort of a miss, not bad, but heated, and sort of people talking past each other. And so when we looked at what this problem was and the spaces where we see infrastructure as code as being very valuable, and it is very valuable, we felt that we needed to have a deeper conversation and to think about how infrastructure as code breaks down into a couple of pieces that we sort of describe as infrastructure as code, and yet isn't just infrastructure as code. It really has to do with how we want to manage infrastructure. So what some people would consider cloud native infrastructure, or cloud 2.0, or just cloud, is a lot of times what people want infrastructure as code to be. It's a very aspirational definition. And so let me decompose it. There is, of course, just normal infrastructure as code that people think of as I write a file, a lot of times in YAML, and then I save that in Git, and then I send that YAML file to Kubernetes, to RackN, to Terraform, you name it, and it goes and builds things. I consider that pragmatic configuration, not infrastructure as code. Most people, when I talk to them about infrastructure as code, they're talking about something bigger than just a YAML file that they inject into a system. Although on the surface, that is infrastructure as code. The other thing that comes with that is this dynamic infrastructure component. And dynamic infrastructure, like an infrastructure as a service, although we shouldn't limit it to that, is this idea that I can ask an API or a platform for something and deliver that. For a cloud, that might be a virtual machine. For Kubernetes, it could be a container. For RackN systems, it's a physical server with everything configured. And so it's this broad range of infrastructure, but the idea here is that we're thinking about it in dynamic terms, not static infrastructure. So we're moving away from this, sort of I take a piece of machinery and I set it up, to I have a much more dynamic infrastructure. That leads us to the next point that a lot of people are really excited about, which is desired state, or a state reconciler pattern. In that case, what we're doing is we're saying, here is my desired configuration file, that initial infrastructure as code component, but we need a way to take our dynamic infrastructure and make it conform to that desired state. And that is a big piece of what infrastructure as code ends up being. It's this idea that I've taken a description of what I want, and I've asked my systems, I've asked a platform to go build it, and it turns out to be that way in the end. So those things must go together. Just giving me a YAML file and saying, here it is, does not satisfy the problem. We have to be able to take this idea of going from source control, which is my fourth point, right? Take something in source control and give it over to a desired state platform and let it go build that. That's a very big point. That's how these things work. One thing that's important, though, is this isn't just a one-shot deal. The infrastructure as code discussions usually revolve around an ongoing change to the existing infrastructure. So dynamic infrastructure would tell you, I'm going to go take this file, I'm going to tell my desired state system to build it. That sounds great. And if I make a change to that configuration, a new version, I can ask the desired state system to fix it. That's a very big part of this conversation when we talk about infrastructure as code. It's not just, can I build my cluster the first time, but can I adapt, change, fix, tear down, extend my cluster? That is really what people get excited about when we talk about infrastructure as code. And unfortunately, it's sort of lost in the whole definition of the phrase infrastructure as code. Included in this ends up being a degree of composable automation, or modular automation if you prefer. And the idea here is that we don't want to just write custom code that goes and deploys our configuration. We've been doing that for a long time. I've seen some lovely bash files that do amazing amounts of configuration as infrastructure as code, but they're really not composable. So you have to fix the whole file and you have to depend on everything being just right. That's the spaghetti infrastructure as code, if you want to think about it in those terms. What we're looking for is high degree of reuse and composability, the object-oriented modularity for infrastructure as code. And that's really a requirement here because we don't want everybody to write their own modules. The idea with any code-based infrastructure is that you've got a model that lets you reuse pieces so that you're only writing the things, the unique business logic, the unique components and unique infrastructure pieces that you require, and you can depend on libraries to accomplish most of your tasks. That's also infrastructure as code. And then finally, this idea from code deployment with the CICD pipeline is essential in infrastructure as code also. So when we look at infrastructure as code, we really want to create a continuously integrated data center where we're going from a configuration, a desired state configuration, all the way through the actual deployment, which could mean building your infrastructure. For us, it goes all the way down to RAID and BIOS configuration and updating that and patching it and installing operating systems. But it really doesn't matter. The idea here is that it's a CI/CD pipeline for making all this stuff work so that your configuration files, the things that you're creating, don't just get pressed into production deployments right away. They can actually go through a controlled process and go through a test dev cycle. They can go through blue-green deployments and make sure that everything's working before you've done a massive rollout to your entire fleet. All 6 of these components are really what make infrastructure as code work. And not just one of them. And the sad thing to me is that we don't really have a moniker right now. Maybe DevOps or SRE, Site Reliability Engineering, sort of these broad terms. But when people think about how specific we are about codifying our automation, we've sort of taken this one small piece of it and let it represent a lot of people's objectives for getting infrastructure as code built. And that's a big piece of that. One other thing that comes up for us in a lot of conversations when we think about infrastructure as code is developers versus ops, right? I know that we've broken all the silos down with DevOps and the world is at peace between the two camps. But for those people who haven't reached that end state yet, what we really see is that infrastructure as code has some developer approaches and inbounds. We see that with things like Terraform, where it's very developer friendly. And then there's operational models. The things that RackN has been doing are building from the operational side, the physical layers up, and thinking about how operators want to interact with their environment and the ways they want to have things stable. And so infrastructure as code also has a duality to it that isn't yet reconciled in market between what developers want to do from writing code and what operators need to do from managing infrastructure. And that's a challenging problem and something that needs to evolve over time. It's something that we've been thinking about quite a bit in how you make a system that is codified, able to have desired state, able to have composable units, be pipelined, and have the modularity that we want to have, and yet create very repeatable, predictable outcomes. Hope this discussion has been helpful. We're going to be having this quite a bit more, doing some live presentations and some blogging about it. So please join us in this conversation. If you have thoughts or extensions that you'd like to see us consider, please let us know. I am Rob Hirschfeld at RackN. I'm Zehicle at Zehicle, Zehicle online, and we'd love to hear what you're thinking. Thank you.